Well friends, now I'm going to take you into a tour of Laplace transforms. We've already seen that Laplace transform is one of the very important integral transforms. There are several other transforms which are used in engineering. Subsequently, we'll be discussing the Fourier transform and the Z transform also. But Laplace transform has got its own importance, not only in electrical engineering, but it's an extremely useful mathematical tool. I will first define the Laplace transform. I will also tell you under what conditions Laplace transform can be evaluated, that is existence. And then subsequently I'll mention three areas where the Laplace transform is effectively used. In order to get full control over this tool, you must know the basic definition, the properties, the areas where it can fail, and subsequently we can see how to approach a problem. First, the recognition is very important, whether it is basically a Laplace format problem or whether we have to look for other tools. The Laplace transform basically, when we define it, looks like an improper integral. But the thing is, as you all aware, that any transform tool will involve a change of domain. So the Laplace transform will take a problem from the time domain to a complex domain. One must be very, very careful to understand that we must not casually use the word frequency domain. The frequency domain should be used only when we are dealing with analysis of frequencies. Now that is very typical about the Fourier transform. So the Laplace transform is basically to analyze electrical circuits, particularly for transients. So let me tell you how mathematically a student should understand the Laplace transform. Suppose we have a function f of t, where t is the variable of time. So clearly, the range for the time variable will be 0 to infinity, 0 included. Of course, infinity cannot be included. Now this function f of t is Laplace transformable under certain conditions. These two conditions are extremely important, otherwise you cannot really transform. The first one is f of t is piecewise continuous, right? There must be no jump discontinuities. That's very, very important about these things. And the second important condition is f of t should be of exponential order. Now one must understand the meaning of an exponential order function. I will write the definition of an exponential order function here.